Okay, now we will be starting with our problem 2. Problem 2. The problem 2 is, it says the beam has a weight of 3.5 kilonewton. Determine the shortest cable ABC that can be used to lift it if the maximum force the cable can sustain is 7.5 kilonewton. Okay, let us start. We are given weight which is equal to 3.5 kilonewton. We are also given maximum force which is equal to 7.5 kilonewton. What are we looking for? We are looking for length. Length is unknown. Okay, so let us start. We start by resolving our component, our horizontal forces. For horizontal forces, okay, let us first start by our free body diagram. Our free body diagram is going to be like this, and this is weight, this is FT AB, and this is going to be FT BC. Okay, we are going to take left as positive and right as negative. So let us start. We have T, the cos of theta, minus T, the cos of theta. This is equal to 0. T cos of theta minus T cos of theta is equal to 0, which is equal to 0. So now let us move on to our vertical forces. For our vertical forces, we have FTBC y plus FT AB y minus weight, which is equal to 0. We have two forces that are going upward and one force going downward, so we're taking upward as positive and downward as negative, hence the weight is negative, hence we are subtracting the weight. Okay, this is going to be T, the sine of theta, plus T, the sine of theta, minus our weight. The same is it is equal to 3.5 kilonewton. Okay, equal to 0. T sine theta plus T sine theta minus 0.5. T sine theta plus T sine theta, this is equal to 2T sine theta. Guys, here we are looking for an for theta. Okay, 2T sine theta. So obviously, since we are looking for theta, we're going to divide both sides by 2T. So we'll be left with sine theta which is equal to 3,5 over 2t, which will be the theta is equals to the arctan of sine into 3,5 over 2. They said our maximum force is 7,5. Going to punch this in calculator and we will get 13,49 degrees. Since we have found our angle, we can use our angle to get we can use our angle to get the length of the shortest cable. Okay, remember okay yeah okay remember our object is symmetry, so it is in symmetry, which means the length from AB is equal to, yeah, our object is in symmetry, which means this 3 we can divide it into 2 equal side, which means now we will have our adjacent side. We have our adjacent side. We have our angle, which is theta, and also, but we don't have our hypotenuse. So we have adjacent and hypotenuse, which means we can use cos. Cos theta is equal to adjacent over hypotenuse. We say cos 13,49 is equal to 1,5. Remember I said that this is in symmetry, so which means we can easily get the, which means we are only going to divide the distance AB, so that, which means the triangle ABC can be divided into 2 parts, and also the adjacent side, of which when we divide the triangle into 2 sides, we'll be left with it's going to be 2 right angle triangles, and from the 2 right angle triangle we can now find the length of AB. So let us continue finding the length of AB. Length of AB is equal to 1,5 over the cos of 13,49, which means the length of AB is equal to 1 comma, we will press this into calculator. When we press it in calculator, we get 1,543. 1,543 meters. Don't forget your sign meters. We have now found the side. We have now found the length of AB. For us to find the length of ABC, the length of ABC is equal to 2 times the length of AB, or 2 times the length of BC. In this case, we have the length of AB, which means we can use the length of AB to find the length of what? BC. Since these two triangles are in symmetry, it means that the length of AB is equal to the length of what? Of BC. Therefore, the length of ABC is equal to 2 times the length of AB. Okay, let me 2 times the length of what? AB, which is equal to 2 into 1 comma 543, and you're going to get 3,09 meters. This is the shortest. The question was saying we should look for the shortest cable ABC that can be used to lift the maximum force, and the cable that can be used to lift if the maximum force of the cable, if the maximum force the cable can sustain is 7.5 kilonewton. Now we are done with that. Okay, let me erase this since we are done. I will need space for our graphical method. Okay, now we will be doing the graphical solution, but we'll be focusing on the first polygons. For our graphical solution, the scale that we're going to use is 1 centimeter, equal to 1 kilonewton. 1 kilonewton. We're going to start with the force that we are given, which is weight. We'll start with the force that we are given. This is weight. From the hair from the tail of the of the of our vector, we are going to draw a line that represent force tension force of AB. Then from the head of our vector diagram, we will be drawing what? The force tension force of what? Of BC, and this one is the tension force of what? Of AB. Remember, this is going to be at remember the force TB is applied at an angle of what? Of theta. So from here, after you have drawn you have measured your things, remember to, when you are going to look for the angle theta, you will use the protractor to find angle theta. Then from there you will measure using your ruler. You are going to measure your thing. Okay, now we're done with problem 2. We are going to problem 3. Problem 3, it's saying if the 5 kg block is suspended from the pulley B and the sag of the cord is D is equal to 0,15, determine the force in cord ABC. D is equal to 0,15 millimeter. They're saying we should determine the what? Determine the force in cord ABC. Determine the force in cord ABC. Okay, so here we're going to start with our free body diagram. Let's start. And our free body diagram it be so They're saying the 5 kg block is suspended from the pulley B and the sag of the cord is D is equal to 0.5. Determine the force in the cord A, B, C. We are determining what? The force. In cord ABC. Once again, triangle ABC, it can be divided into two. It is symmetrical. Which means AB is equal to AC. Let us do it now. We have FBD and we have force AB and also force, this is AB and BC. So let us get into calculations. Let us go into calculations. We are given mass. Remember, we are given mass, which is 5 kg, which means we can calculate weight. And remember, FBD is equal to weight. Okay, let's check. Weight is equal to mg, 5 into 9,81. 9,81. Let's erase this. Okay, good people. We are now going to get 5 multiplied by 9,81. Let me punch this in my calculator. We are going to get 49,05 newtons. 49,05 newton. Since we have let us find the angle so that our work can be easy. We have our adjacent and we have our opposite side, which means we can find the angle using the tangent. Tan theta is equal to opposite over adjacent. which is going to be equal to tan theta is going to be equal to 0.15 over, remember it is in symmetry, which means we're going to divide 0.4 by 2 and we're going to get what? 0.2. Therefore theta is equal to the arctan of 0.15 over 0.2. Theta is going to be equal to 36.87 degrees. From there, let us resolve our components. Let's resolve our component. Now we are going to actually solve for our force using our equilibrium equation. So we're going to F of y is equal to the sum of vertical forces. They equate to 0. Remember that FTAB is equal to FTAC, which means there's no need to write them two, so we can just say 2 times is going 2 into FT, the sine of theta minus weight is equal to 0. I'm going to say 2 FT, the sine of 36.87 equal to, remember our weight, we calculated it and we found it to be 49.05. So here we are looking for FT. 2 FT sine of 36.87 is going to give you 0.6. Which is equal to 49.05. 1.2 FT, 2 times 0.6 is 1.2. Is equal to 49.05, which means FT is going to be equal to 40.88 Newton. Now we are done with the analytical solution. So let us go to the graphical solution. I'm sure you can see what I did here. Okay, let me explain to you what I did properly. The question was if the 5 kg block is suspended from the pulley B and the sec of the cord is 0.15 meter, determine the force in cord ABC. Neglect the size of the pulley. Well, determine the force in cord ABC, and you neglect what? The size of the pulley. Our first step, we first draw what? Our free body diagram. As you can see, FBD is acting downwards. FBC is acting at an angle to the right, and FAB is acting at an angle to the left. Okay. The first thing first, we are giving the mass. What? But we are giving the mass of the block, which means we can calculate weight. What is weight? Weight is equal to mg. This is the standard formula. Then we are going to say 5 into 9,81. We're going to say 5. 5 is our mass. The gravitational constant is 9,81. 5 multiplied by 9,81, you're going to get your weight, which is 49,05 Newton. After that, you're going to calculate what? Your angle. Judging from looking at our system here, you can see that this triangle is symmetrical, which means that the 0,4 meter can be divided into 2, and AB is equal to what? BC. Which means we have opposite and adjacent. So for us to find the angle, we can use tan theta. Okay, we can use tan theta. So we're going to say tan theta equal to 0,15 divide by 0,2. The 0,2 we get it from when we divided the 0,4 by 2. That's where we got it. For us to find the angle, obviously we have to use what? Then tan, the arc tan of 0,15 divided by 0,2. Then we're going to punch it in the calculator. You find the answer, which is 36,87 degree. From there, you're going to say the sum of vertical components is equal to 0 degrees. After getting the sum of vertical component, always remember that the force that occurs at AB is equal to the force that occurs at AC, because the triangles are symmetrical, which means on our sum of vertical forces equation, we can substitute ft sin theta and multiply it by 2. Then substitute weight. Upward, we take upward as positive and downward as negative. We have two forces going upward, which is represented by 2 times ft sin theta minus our weight, which is going downwards, equal to what? 0. 2. So we're going to substitute our values now, which is 2, the ft tan of 36,87, which is the angle that we got above, and equal to 49,05. Then 2 ft, when we punch sin 36,87 on my calculator, you're going to get 0,6. That's what the 0,6 comes from. From there, you're going to take 2 multiplied by 0,6, you're going to get 1,2 ft. We are looking for tension force, which means for our tension force, we're going to divide both sides by 1,2, and we're going to get 40,88 Newton. That's how we got to our answer. Now we are going to do this on. Now we're going to solve this graphically. Now we're going to solve this graphically using what? The first polygons. Okay. Okay, we're going to start by drawing. I made a mistake here. Okay. Remember our scale. 1 centimeter is equal to 10 newtons. Let us start with the given force. The given force, this is what? Weight. From the head of the, from the tail of our vector, we're going to draw a line representing F T B C. Then from the head of our vector, we're going to draw a line representing what? F T A B. Remember our weight is 49, then from there you're going to measure your things. Afterwards, after that you will get the estimate. You will get our estimated value. Remember, I'm not using a ruler, so I can't necessarily show you my values. Okay, let us now erase this. We're gonna go to problem 4 now. We are going to go to problem 4. For problem 4 says if the mass of cylinder C is 40 kilograms. Determine the mass of cylinder A in order to hold the assembly in the position shown. Okay, here we can see that EB, it is applied at an angle of 30 degrees. Then ED is applied horizontally to the left. Then EA is downward and BC downward. Okay, let us draw our free body diagram. When you're going to draw a free body diagram, we're going to draw a free body diagram of forces affecting what? E. For our free body diagram, you're going to have at FTEA. You have a horizontal force which is FTED, and also you have EB which is applied at an angle of what? 30 degrees. FTEB. We have FTEB from here. From here, we are going to find our we're going to do our answers now. We're going to work out our problems step by step till we get to it. Okay, I will do my problem here. But if the mass of cylinder C is 40 kg, determine the mass of cylinder A in order to hold the assembly in the position shown below. So, if you can see here, the weight of C is equal to FTBC, which is equal to FTEB. Let me write this down. The weight of cylinder C is equal to FTBC, which is equal to FTEB. From here, we are going to and remember for DE, ED, remember for not ED, for FTEA, remember this is equal to the weight of cylinder A. The weight of cylinder A is equal to force TEA, and the weight of cylinder C is equal to the force FTBC, which is equal to FTEB. Yeah, let us get into calculations now. The weight of cylinder C is equal to mg. Which is equal to, this is equal to (392,4 Newton). We got it by multiplying 40 and 9,81 on a calculators. From there, let us find the sum of our, we are going to find the sum of our horizontal forces. Sum of horizontal forces, they are equal to 0. Take left as negative and right as positive. Remember to always take left as negative and right as positive. Upward as positive and downwards as what? As negative. Okay, so it's going to negative FTED plus FTEB, which is equal to 0. So we're going to say FTED is equal to FTEB cos of 30 degrees. So from here we're going to find the sum of vertical forces. For our sum of vertical forces, we have FTEB sine of 30, which is equal to minus FTEA. Remember, FTEA is that cable that is hanging, of which is equal to the weight of that cylinder, which is equal to this is equal to 0. Okay, let us substitute our values now. This is going to be 392,4. The sine of 30. This is equal to FTEA, which means FTEA is equal to, when you punch this on a calculator, you're going to get 996,2 Newton. Remember I said FTEA is equal to the weight of A. And remember the weight of A. Remember FTEA equal to, weight is represented by mg. Okay, FTEA, we have our value, which is 196,2, is equal to, our mass is what we are looking for, into 9,81. We're going to divide each side by 9,81. 9,81. 9,81 and 9,81 are going to give you what? Mass is going to be equal to 196,2 divided by 9,81. We are going to get 20 kg, and that is how you're going to get your value. That is how you're going to get your value for mass. Mass of cylinder A is equal to 20 kg, and